All right, fellas, thanks for being here today. Like I said before, this is the second part of the three-part webinar where we're going to go from learning how to measure like we did on the last one to now using those measurements in the design and the learning plan from experiments that we can run on a farm so that those measurements actually teach us something that we can use in the ongoing process of improving the management of the enterprises that we have. So we're going to go systematically through, first of all, why bother to do this? Because, of course, it represents extra work. And then we'll go into the steps to creating a proper plan for an experiment and getting the most out of it. And then we'll also talk about just some tips and tricks that I've learned from coaching other people to do this and from running experiments on my own farm that can go a little bit deeper than the simple formula at the beginning. So, why bother to do this? Like I said, this represents a little bit of extra work and it requires some planning and some structure. So let's make sure that it's worthwhile for that extra time. The basics of it is that whether or not you treat it this way, everything that you do on your farm is an experiment. So you might as well get the most out of it. There's almost nothing that you can guarantee a result on with all of the variables and all of the different things that could come up during a farming season, even if they worked for you in previous seasons. We all know about the variability in the weather, fluctuation in prices and markets, even the lack of loyalty of buyers sometimes. And so we really need to be treating everything that we're doing as an experiment so that we can start to improve the processes and our chances of success over time. One of the benefits of running your own experiments, or a list of benefits, is that you can answer specific questions that you have. If you're waiting on research or information from other people, it might give you some answers that are not specific to your context. And so having these context-specific ways that are relevant to your ways of farming, your climate, your region, your markets, your resources is also extremely useful. Experiments also need to work within your time frame and your priorities. Sometimes things come up and information that is given to you in a package or that was run in a different place is not going to adapt to the things that happen in real time as you adapt to the realities of what's going on in a season. And your experiments can also be flexible to the variables and the changes that happen on your farm, whether they be personal or outside of your control. Now, there's different types of experiments and research. So let's get into the different types before we go into a process of how to actually move them forward. Many of you are already familiar with these dualities here. There's the reductionist scientific method, and then there's the systemic or the holistic way of doing research. And we'll look at both of them because they each have advantages and disadvantages. The reductionist experimentation is something that is often maligned in the regenerative ag world, that when we look at things through a reductionist lens, we miss the bigger picture. But there are some really useful things that you can do with this system. You can isolate a certain part of a whole farming system in order to explain how that part works or responds to certain changes. This is most of the types of experiments that you're going to be able to do because the other ones require a lot of resources and large scope. The advantages here are that it's good for gathering very specific information. You can get yes or no concrete answers to things, and you can evaluate between a few different things and some controlled variables. The disadvantages are that it misses the bigger picture and the complexity of a farm in its entirety, but it is good for getting some straight answers. There's two types of reductionist research or experimentation that you can do. There's qualitative research, which is usually expressed in words. It is used to understand concepts, thoughts, or experiences. This type of research enables you to gather in-depth insights onto topics that are not super well understood. Common qualitative methods include interviews or open-ended questions, observations described in words, and literature reviews that explore concepts and theories, kind of like what I do on a podcast. And quantitative research is expressed in numbers or graphs. It's more concrete, but it's also more reduced and misses some of the nuance. It's used to test or to confirm theories and assumptions. This type of research can be used to establish generalizable facts about a topic. And common qualitative methods include experiments, observations recorded as numbers or as surveys with closed-ended questions. Let's talk about system scale research. Now, like I said, this is probably going to be outside of the scope for most of us. These system research projects are usually really large in scale, and they take place over many years or even decades, and often involve research from multiple disciplines. The advantage is, of course, that it gives you insight into an entire system, acknowledging complexity and relationships in a way that reductionist observation does not. The disadvantage is that you might not get a clear answer or any hard data at the end of it. Maybe a better understanding of something, but nothing that you can point to as concrete yes or no answers. So it's good for pattern and cycle understanding, which is just as relevant when we're working with the complexity of ecosystems or communities. And I use these graphics here because this is something that Climate Farmers is directly engaged in. This is a graphic from a collaboration that we've done with another organization in an attempt to map the agri-food system in Europe, as well as the relationships, the cycles, and the patterns that make decisions within this system and that we need to find leverages in if we want to make change in the system. This link at the bottom I will share in the chat after we're done speaking, because you can access the research and the collaborations that we've done already if you're looking to understand this a bit for yourself. Now, how do we understand systems at a farm level? If we're trying to make this manageable, this large scope that I just talked about, there are some ways that we can approach this that are accessible, even if you don't have a big budget or a ton of collaborators. So first of all, you have to broaden your vision. You want to look for patterns and cycles and not only answers, facts, and data. And you need to measure and track meaningful indicators in the three main categories that I've spoken about in the last one. These ones are the ecological health, the economic health, and the human community health that is directly related to the actions and the decisions that you take on your farm. We'll revisit this in a minute, and this has a lot to do with the resources and the digital tools that we've been building here at Climate Farmers. So those are all good reasons to get started. Let's figure out how to get the ball rolling here. I'm going to go through 10 steps, partly because there's a lot of published literature on this already. There's university programs, there's grants and such that promote on-farm experimentation. And so this is the kind of the conventional approach. And then later I'll talk about some of my own experience and why I would change some of the order of development of these steps for reasons that I'll explain in a minute. So the first one is to identify your research question and objective. We can actually open this up to a conversation with those of you who are here. So what are some of the questions that you wish you knew the answers to? I'll give you some examples here. So think of a question as a comparison between two or more practices. For example, can a legume cover crop substitute for my standard commercial nitrogen fertilizer application? And if you write it as an objective, it's even more useful when you're trying to get an example or when you're trying to get a result. So example here would be, my objective is to determine if a legume cover crop will supply enough nitrogen to meet the needs of my subsequent cash crop. The simpler the research question that you give, the simpler the project will be to conduct, because you'll have a very clear thing that you're trying to answer. So with that said, does anybody here have questions that they would love to get answers to? Because maybe we can use this as an example throughout this presentation that we can build an experiment around. Anybody got a question they'd like to address?
I have one.
Go for it, Amanda.
Oh, great. I want to know if I'm spraying an amendment that has microbes in it, like worm manure tea or some kind of jadam thing, if I can also at the same time in the same solution spray something that has pest reduction qualities, like soap or like a hot pepper or garlic spray that gets rid of, that's avoiding, I don't know, whatever pest I'm trying to get rid of. I've been wondering whether I can just make it one pass with a sprayer or whether I need to make two sprays.
Yeah, that's a really good question. So you're trying to figure out if your microbial inoculant will still be effective if you're also mixing things that could have antimicrobial effects in the solution. Is that correct?
Yeah. Yeah.
Okay, so we'll use that as an example as we go through these other steps about how we might be able to develop that into a hypothesis and then an experiment to go along with it.
Okay.
Does anybody else have a question that maybe we could use as an example as we go through this?
Types of the same question, but types of legumes. Because, for example, right now on my pears, I wanted to buy a legume, sorry, legumes, but this el trébol.
Trébol is clover.
Oh.
Yes, so I wanted to buy different types of those, but it happened that it grew naturally different types of them. The red one and a small yellow one. And I was amazed, and I was wondering to apply more of those or apply a different type of it to mix more diversity of it.
Mm. So what was the question, or what are you trying to figure out within that? Because it has to do with the objective that you want from the experiment.
Yes, to the nitrogen. If I should wait for a natural cycle of the native crop, or if I should seed more for next season.
Okay, so maybe we could phrase that as an objective, which would be, can I get enough nitrogen in my soil from existing legumes? Or will it be necessary to supplement with some legume seed?
Yes.
Something like that, right?
Yes.
That's a great example. Thanks, Felipe. All right, let's go on to the next step then. So now we can develop that objective or that question into a proper hypothesis that can give some structure to what it is that we're going to be experimenting with. So the hypothesis gives an indication of what is actually going to be measured in this experiment. And here we can start to clarify things through the common question words in English: what, when, how, where, who, why. These are the things that, as much as possible, we want to fit into our hypothesis so that we know what it is that we're looking for when we go into experimentation. And there's some good examples here. So like I mentioned before, can a legume cover crop substitute for my standard commercial nitrogen fertilizer application is the main question. The hypothesis could be a cover crop of hairy vetch before my cash crop will provide enough nutrients through the season to achieve my target yield. The hypothesis is making an assertion of what you think will happen, and that the experiment then will be looking to prove or disprove. Now, later we'll talk about trying to maintain a lack of bias, even though we've already made an assertion, so that we don't put our hands on the scale, so to speak. But let's use that through the examples that you gave, Amanda and Felipe. So the first one about checking the efficacy of a microbial inoculant with also a potentially antimicrobial addition. You could say, I believe that a microbial inoculant with an antimicrobial, let's say, what are you using as an insecticide or as an antifungal, perhaps?
Well, yeah, I mean, well, actually, yeah, not insecticide, slugicide.
Okay.
I read that it's effective against slugs and snails. So
Got
yeah,
it.
molluscum.
So
Or
the
deterrent.
hypothesis could be that using a microbial inoculant with one of these other additions will continue to get the same results as a microbial inoculant without.
Right.
Yeah, so that would be the
Yeah.
assertion that you think could happen, and then you design the experiment around to prove or disprove. Felipe, in your case, about adding an extra legume seed or just relying on the ones that sprout naturally in the field, maybe one way that we could phrase that is, I believe that we can obtain enough nitrogen from the native legume plants in our tree rows without the need of adding more. Or you could do it the other way, where you're trying to validate the use of extra seeds by saying, by adding extra legumes to our cover crop, we will increase the available nitrogen in the soil by X%, right? So you could the thing with the hypothesis is that you can aim to prove an idea or disprove an idea, whichever one you want to invest the time in, right? So yeah, and then these other examples here. This is where it's a little bit subjective. There's not a right or a wrong way to word your hypothesis, but you'll get better at it over time as you gain experience in creating the experiment that will prove or disprove your hypothesis. From there, we need to figure out what you want to measure and record in order to answer your questions and test the validity of your hypothesis. Basically, this is very close to what we talked about last time. Your metrics need to give clear and verifiable insights into your progress towards your unique goals. Having this related to something that is meaningful for you in the quality of life you're trying to obtain or the clear objectives that you are hoping to achieve through a farming season will make it that much more likely that you will follow through all the way with, right? Because we all have kind of casual questions that we would like to have answered, but they're not important enough for us to do real extra work and analysis to find out. So I'll go more into this a little bit later, but aligning the experiments that you run with something that's really meaningful in your lifestyle or in your business really helps to make sure that you follow through with it all the way. You should also have the knowledge and the equipment to do your own measurements at the right time and in an accurate way. Relying on somebody else to show up and do the measurements for you can fall through. If you don't have the right equipment, this can also mean that you're going to get poor results or that you won't do it at the right time. All of these things are important in order to get the quality of information that you need from your experiments. You also need to plan for measurement and monitoring in order to get the information on time. As important as doing the test right is doing it at the right time in order to get reliable information. And we've got a template that makes this a lot easier. You can go pretty detailed in the design of experiments, but just like I mentioned before, by keeping them simple, it's more likely that you'll actually follow through with them all the way. And it's more likely that you won't get overwhelmed during the season and drop some parts that are essential to the entirety of the learnings. And so this template is actually one that we use in a lot of different ways within the Climate Farmers team as well. We run experiments all the time with, whether a marketing campaign is going to be effective, whether people have difficulty moving through processes in our products. And this is essential for us to keep up with the learnings that are necessary to be effective in our work. And I've also put this to use with farmers many times in the past. By answering or going through each of these 4 sentences, basically, we can simplify the design of our experiments and make them really clear and straightforward. So as I mentioned before, we've already developed a hypothesis. We're making an assertion about what we think is going to happen from the actions or the treatments that we're going to trial. And then from there, that goes into the we believe that statement. So we believe that, let's say, the legumes in our fields are adequate to provide available nitrogen to our tree crop. To verify that, we will. And this talks about the action that you're going to do in order to test that hypothesis. And measure, this is the clear measurements that you're going to take that will prove or disprove your hypothesis. And we are right if. So this is the clear measurement result that will give you a definitive answer as to whether or not your hypothesis was correct or not. Let's make it easy. Let's go to an example. So applying compost tea will increase yield by 10%. If we were to use vague language like increase yield without that number next to it, it's hard to say. Let's say you went through this experiment and you got an increase of 1%. Well, is that worth doing again? Is that conclusive evidence? Because there's always a margin for error when you're doing measurements. And if your results are that there was a 1 or 2% increase, that is not conclusive evidence. When we go into the verification, we can say by applying compost tea once a week during the growing season, we will then measure. Here, the specificity of the frequency of application is really important, because if we just say apply compost tea and measure, That doesn't say how many applications, the frequency of any of these things. So having some detail and specificity in what you write is key to then being able to plan for proper execution of the experiment. And measure the yield after harvest compared to the control sites. This having a control here is really important because if you don't have something to compare it to, it's very hard to know whether the treatment or the experiment that you're running is the reason for the results that you get, right? So for example, if you're testing the difference between the efficacy of your bioinoculant with or without, let's say, hot chili peppers that could have an adverse effect on the microbes, you need to have one bioinoculant without the chili in it to see if there is a marked difference between one or the other. And ideally, you also have one area that doesn't get any treatment at all. That would be your proper control, so that you could say, first of all, the bioinoculant had some effect that is a marked difference between your control and your experiment. And then the one that had the chili or the chili oil in it shows a marked difference between the bioinoculant without than the one with. If you don't have these other things to compare with, how do you know if the results that you're getting are because of the variable or the treatment that you're testing? That part's really important. And we'll go into more detail on that in a second. And then, of course, we are right if the crops or the crop area which we've applied compost tea to averages 10 or more % of yield. Now, when you're putting these numbers, these verifications of the efficacy or not, it's important to do something that is realistic and conservative. Nothing in nature gets 100%. But likewise, nothing gets 0%, right? There's variables outside of that that will always mess with it. And going too specific in details, let's say, for example, instead of 10%, we put 5.4%. That level of specificity is unnecessary, right? These rounder numbers will give us an area in which the margin for error that we are testing for is accounted for. Depending on what you are testing, this could be a large margin, anywhere from 5 to 10%, or if you have very accurate methods and precise tools, you might be able to diminish that to 1 or 2%. So keep that in mind when you're putting the numbers that will verify or disprove your hypothesis so that you can have something conclusive by the end of it. And here we can say that if there is a 10% or more increase in yield, that's fairly safe that we can conclude then that the compost tea had something to do with it. Now, I just talked about the importance of having controls, something to compare the results to so that you can confidently say that what you were testing was the reason for the results that you got or not. Now, it's easy to rely on this idea that, oh, I'll just have one control over here, and I'll have my test plot or the treatment there or the practice that I'm testing over here. Well, that can often lead to pretty unreliable results because there are many variables out in the ecosystem itself that could be competing with this. The hypothesis gives an indication of what will actually be measured in the experiment, and then you want to configure your test to account for the variables on the field. Just like I said, the margin for error in your testing, all of these things we can start to plan around in order to either control or eliminate the variables that could throw off our information. The graphics here give different ways that you could configure your control and your treatment area or your multiple tests if you're doing many different types. So if you've got, let's say, 3 or more types. Let's assume here in this graphic in the middle that you've got blocks in which there is a different soil composition. So for example, if we split this in 2, you might be testing either the control or the treatment on an area that has different soil conditions. And so the results of your experiment might be different just because the conditions of the terrain were different, not because of the treatment or the test that you did. By randomizing this, you can much more likely get conclusive evidence that isn't just determined by the variability out in the field. For example, next to it, let's say there's a big gradient, and chances are you've got more fertile soil towards the bottom of the field than you do at the top, just because of how geology works. By randomizing your treatment plots and your control plots, you're not any longer limited by the fact that there are differences in fertility along that gradient, but rather you've got control and tests at multiple spots all along those blocks, so that you can say, well, despite the differences in soil at these different levels, I've got examples of both the treatment and the control in each level, and that will help to average out the results that you get all along that pendiente, desnivel, English. You know what I'm talking about. That will give you better results on your experiment. And there's lots of different configurations, which I've got all these graphics here to show. For example, if you're doing something like a compost tea or a spray, sometimes you need to have border rows that will give you a buffer in between areas of either control, or let's say the farmer next to you is spraying pesticides or fertilizer, and you want to make sure that your experiment is not thrown off because of drift of those products. Having borders or buffers around the areas that you're testing is also something to consider. And all of this stuff is something that we go into more detail about in the program. So this is just to give you something to start with. Now, of course, I love templates, and we've got more templates for you here. So when it comes to actually planning and preparing for what you're going to be doing out in the field, it helps to have considered all of the different things that are going to be relevant to getting the proper results and executing in a timely manner that is going to lead to conclusive evidence by the end. So this template gives you a way of naming the project, clearly stating the objective, having a list of the metrics that you're going to track, the measurement dates so that you track it in a timely way and get quality information. You can write out your hypothesis there. And there are lists for things like the key actions, either in management or in product use, that is going to be part of the experiment, the time frame in which this is going to happen, not only in the actions, but when the whole thing occurs. You can list the people who are responsible for each of the actions, the time frame, the materials that are necessary to carry out the tasks, and the budget for each of those things, so that you don't either go over budget and not be able to complete something by the time it gets underway. This is exactly what we're going to be going into detail in on the third webinar, so I'll leave it there for now. Next step, implement the project. I don't have a whole lot to say about this. By the time that you've got your experiment planned out and your preparation and your plan through those templates done, implementation should be the easiest part. Just go out in the field and follow the plan that you've made for yourself. Along the way, it's really useful to make observations and keep records throughout the duration of that experiment, because there's often a lot of things that come up that either you didn't plan for in the beginning, or that are relevant to some of the observations that maybe were not part of the main objective of the experiment, but are still relevant to getting as much learning as possible. So your metrics, of course, need to give you clear and verifiable insights into your progress towards your unique goals. You should have the knowledge and the equipment to do your own measurements at the right time and in an accurate way. Sometimes this means just knowing how to take good soil samples if you're sending them off to a lab, if that's what you're looking into. And of course, you also need to have a plan for measurement and monitoring to get valuable information on time. I'll keep saying this stuff because if you don't get quality information, it's kind of not worth doing this at all. And bad information can give you, let's say, conclusions that are actually detrimental to your management rather than helpful. Now, the last are listed as 3 steps in the conventional way of executing on experiments: collecting research data, analyzing the data, and interpreting the data and drawing conclusions. I'm putting these all together because this is exactly what our digital tool is made in order to facilitate and to make more simple, so that you don't have to go through all of these mathematical calculations and, you know, be extremely detailed and scientific about it. We're trying to make this easier for you. And that's exactly where we come into with the digital tool. So when you create a profile, you put the information of your farm, the information of your production model, your landscape, your business resources, your climate, your context that gives context to the whole experiment. And you can easily record your observations, your metrics and measurements in the dashboard. And we're working to make this even more visually interpretable so that you don't have to, write something down, look at it next to other things. It should be easy to do in the dashboard. And that's going to come out in newer versions of the tool. So now let's go into some of the stuff beyond the simple steps, the formula for creating an experiment that I've found to be really helpful and can make the difference between getting usable information that you can actually use to improve your management, or sometimes even abandoning the experiment for other reasons. So like I said before, aligning your metrics to your unique context is essential. And this is where I swap the sequence of steps a little bit because I found it to be useful. First of all, it's not worth measuring things that you don't care about. This is the problem that I have seen with many other, let's say, certification schemes or incentive schemes where they say, all right, we'll pay you some money. You tell us about how the soil organic carbon changes in your soil from one season to the next. If you don't see why soil organic carbon improves the health of your business or the quality of your life, and you're just sending data to somebody because they say it's important, I have found that very few people either measure that accurately or follow through with the steps and the data. People abandon this stuff because it's not what's really important to them. Don't bother measuring things that have little to no effect on your quality of life. This is why in our program, the first step is understanding and defining your context, which includes a statement of the quality of life that you're looking for, because with that understanding, you can build experiments that are uniquely relevant to what it is you are trying to achieve on your farm. Small little data points and information that's nice to have is great, but I've just seen very few people actually follow through the entirety of an experiment if that's the only motivation they have to do it. There's quite a bit of work that goes into this monitoring. So make sure that the questions or the information you're trying to get are meaningful and relevant to you. The other thing is keeping it simple. There's a lot of different ways to do this, and there's a lot of easy ways to overcomplicate things that can muddy up the waters when it comes to drawing useful conclusions from your experiment. So avoid stacking too many experiments at the same time, especially in the beginning. Keep your first ones really simple, short time frames that you're confident that you have the ability and the tools to follow through on. Minimizing variables through equal management is also very important, especially if you're testing something like a product. So we'll go back to Amanda's example. In that case, you're testing a product. It's really important that you manage the different plots that you are testing in the exact same way, because let's say your timing for mowing the area around some of your trees is different from one of the other test plots. That small variable can change the results and make you think that a product is more or less effective when actually it was just the different way that you manage the different plots in the same time period. If you're testing the efficacy of a product to make sure that, I just said that the treatment is exactly the same. Otherwise, you're mixing product variables and management variables. Keeping consistent management or consistent product application is essential to not add unnecessary complication and get poor results from what you're actually studying. Determine the earliest indicator of success or failure. For those of you who know holistic management, looking for earliest indicators is a big part of their program. The example that they often use is many people wait to see the body condition or the weight gain of their cattle, which is actually a late stage indicator of the health and the nutrition in their pastures or in their forages. Whereas instead, if you look at, let's say, transects or quadrats of your pasture, or indicators on the soil that it's either being covered by more litter or has better infiltration or organic matter, those will change faster than the body condition or the weight gain of your cattle. And you could maybe address those indicators or start to change management practices before it's too late and it shows up in poor weight gain in your cattle or bad body condition scores, right? So the idea here is whenever you're testing something, what is the first sign that things are going well or things are going poorly that you can look for so that you have time to intervene or change course before it's too late, before it negatively impacts your business. And I'll get to that too in just a second. Understanding what you're actually measuring and what you're not. For example, if you're measuring germination rate, that's not the same as yield. You might have great germination rate, and let's say a fungal disease wipes out your crop later on, and that's what affects your yield. So know what you're measuring. Yield is also not the same as revenue or profitability. Maybe you're testing for profitability in your business, and what you're measuring is yield. Well, those are not the same thing. You can't make that conclusion that your yield is the same as your profitability or is the only thing that affects it. Also, run your experiments on areas of your farm that are as close to your house or your main areas of work to make monitoring easier. You will pick up on and notice things so much faster if you are just present in the areas or have a line of sight to them than if you have to drive to the other side of your farm to check up on it. There's tons of stuff that you're going to miss just for not having proximity. Some tips for improving the accuracy of your results. First, plan to run your experiments for at least 2 growing seasons to improve the reliability of the results. You might get really favorable results for, let's say, one product or one new way of managing something that actually has more to do with the fact that you got reliable rainfall over the winter, or that there was lower humidity in the air and didn't cause, let's say, a fungal infection. And only by running that over a couple of years, especially these days, since one season to another can be wildly different, will give you more reliable information as to whether or not the thing that you were testing was the reason for your results, or if the change in variables from season to season was actually behind it. Also, reduce external variables by choosing plots that are as representative of normal on your farm as possible. If you have large variability in your farmland, let's say some areas on a dry ridge on a hill and another is in a swampy area at the bottom of a valley, and you run your experiment in one or two of those extremes, it's probably not going to give you conclusions that you can broadly apply elsewhere. Maybe you get really favorable results on a product down in the humid area, and you go to apply it on the dry ridge. You might get very different results. So the ideal thing there would either be to run 2 separate experiments for the extremes of the differences of your land, or try and pick areas in between, like halfway down a slope, somewhere that is in between wet and dry, something that is generally representative of the majority of the land that you manage. And then, of course, the thing that I'm very good at giving advice on and terrible at doing myself, label and record everything. I always lose my labels, or I write it with something that then gets sun bleached and I can't read later. That's the story of my garden at the moment. Label stuff. It makes it so much easier to keep track of things if you can just go there and read it and say, oh, that's the thing I was looking for. I lose labels, I mislabel, I don't label. Don't be like me. Do as I say, not as I do. And of course, minimize risk. Your experiments need to be need to follow these 2 things, either be fail safe and also be safe to fail. So fail safe means that progress isn't lost or compromised if perfect execution isn't achieved. So this is saying, okay, I know I'm going to go on holiday during part of that experiment period. I have either neighbors or employees or collaborators who are going to be present, who know how to follow up with the measurement, who know how to follow up with the management plan so that it doesn't fall apart while I'm gone, or that you have already pre-purchased all of the things that you need so that you don't get halfway through the season, find out that your supplier doesn't have those things anymore, and you can't finish your experiment. right? So get everything set up, get all of your contingency plans lined up beforehand so that when it is time to run the experiment, things go smoothly. And if one part falls apart, there's redundancies or there's safety built in so that you don't lose your progress. Safe to fail, on the other hand, means that if your hypothesis is wrong, you don't risk losing your whole season or your whole crop or your whole income in a way that could put your business or your enterprise at risk. Pick manageable sizes. Let's say you're trying something radically different. Don't run your test by applying the whole thing to the entire farm all at once. Do it in an area that if it were to go horribly wrong, you can still get a yield or, a sellable product, or, you don't lose or put at risk the whole business. This is what is meant by safe to fail. And the last one is get help. There's a lot of support for farm experiments these days. You can look into getting grants, funding, support to run experiments from local universities or agricultural co-ops. And there's NGOs out there who support this kind of work. And if you're looking for contacts, you can definitely reach out to us at Climate Farmers. We have a lot of these people's contacts and numbers, and we've collaborated with them in the past. But definitely start with your local area. Universities are a great place to start, especially if they have agricultural programs. And at the very least, they can put you in touch with others who support this kind of an effort. So even if you're just getting started, check around your local resources to see what can help to support you in your learning efforts. And of course, how are we making this information and process available to the community? Well, those of you who were here last time will have seen this part. We've got the Farm Measurement and Planning Program. This is exactly what we focus on. And it's important to know that it is not a knowledge-intensive program. This isn't a course where I'm going to teach you anything about practices or management of your farm. Rather, it's a process that you can use to create your own tailored management strategy and adapt it as is necessary as you progress through different seasons, as you improve in your own learning journey and your knowledge, and learn things through your own experiments. It's not graded, certified, or completed. Instead, it is a cycle. You will just keep going round and round and improve at your planning process as you go through it multiple times. As a quick overview, there's 5 steps in the program. We start, like I said before, in creating a unique context that will help you identify what is really important to you and set a baseline for how you create the rest of your management strategy. From there, we go into selecting measurements and metrics that will guide the building of experiments and management plans. And then we'll go into planning and implementation for monitoring. This is going to be the focus of the next webinar. I'll go into more detail about the templates and the processes that we have here. And then reflecting on the learnings. Like I talked about, the digital tool is meant to make this easy for you. So you don't have to have a bunch of random spreadsheets out there doing mathematical calculations to figure out what you learned. And each time you go back around, you improve and you refine your process until it's just second nature. This is just the way that you execute on the management of your farm. We also have opportunities and resources for connecting with consultants or specialists. We have the largest network of professionals, especially in the regen ag space in Europe, and we love to connect people. You can get specialist attention or advice on troubleshooting any aspect of your farm. So even though this program is not knowledge specific, we can make the connections that give you the knowledge to make work happen. And of course, we've got ongoing support for long-term results and can match you with professionals to assist you there as well. And of course, we've got the community. You can compare, contrast, learn, and grow with this entire group of farmers all over Europe. You can see what other farmers around with similar contexts are doing and achieving. You can get advice from experienced farmers, a few of whom are here in this group right now. You can exchange contact and knowledge and see each other's trajectory and basically not be alone in doing this. It makes it so much easier when you've got support of other people who are doing similar things. It can accelerate your learning journey significantly. We can also help you to find the next learning resource that's right for you. So even though you go through a process like this, maybe you need specific information on, I don't know, fruit tree management. Well, we've got the network of online and in-person farm trainings. We can help to match you with workshops in the field, many of which we conduct ourselves through our network, and maybe even recommend courses for in-depth understanding that will help to accelerate your learning journey. And the best way to sign up, I will send you a link in the chat in just a second. And we are also, because we're at the beginning of this stage, we're co-developing this with the farmers who come to the program with us. So you will help to inform the way that it improves and develops over time so that we make the resource ever more useful for the farmers who are using it. And that's it for today. I will open it up now for questions, comments, ideas. I'm more than happy to make time to help you develop ideas for your own experiments right now. But yeah, go ahead. I've got some things in the question here. In the chat, it says, I love crimson clover, and it's an annual and very heavy nitrogen fixer, and one that can crimp it and kill it easily in hairy veg. Nice. One good way that you can measure the efficacy of, let's say, legumes in your field is by counting and analyzing the nodules in their root system. It's one of the metrics that I advocate for in the program. It's one that I just finished doing out in my own fields, even though I did not get a very good indication that they're doing so. You can see the small nodules in the root system, and you can also pinch them to see if there is color in them. If they're white, if they're underdeveloped, they're actually not fixing that much nitrogen, even if the plant looks healthy up above. So yeah, let's see what else here. Oh, Amanda had to take off. Thanks for coming anyway. Appreciate your contributions here. All right, I'll open it up now. Anybody else who's got questions or ideas that they want to develop here?
Hi, Oliver. I've got a question. I'm right now doing testing for neem oil, and basically I want to use it as a way of controlling insects.
Mm-hmm.
And I'm not quite sure, either it's not working, or maybe I'm not doing something right, or I'm not controlling the experiment properly. Because how do you control, or how do you do an experiment on insecticide? Because you can do the best spray and the most effective spray, but then they can still attack you from other places. So how do you isolate your experiment from externalities?
Yeah, so this is why it's tricky with these reductionist experiments. You're always going to be open to some variables and some uncontrolled factors on the land. There's no, confined laboratory conditions that will make this variable free. Have you tested this on areas that have a buffer zone around that isolates it at least somewhat from the rest of your almond fields?
So what we are trying to do is really compare it to one of our neighbors who's not applying it. So we are going, okay, we are going to apply this across our sort of complete field, and then compare it to a neighbor, maybe sort of couple of acres down.
Okay. And
see what the insect pressure is there. So before we started the experiment, we could see both of us had aphids in the fields. And we'll see, how that develops. And the reason we picked somebody a couple of fields down is we didn't want, something jumping from our field to the neighbor field. And so there's a little bit distance between the two of us.
Yeah. So that's not a bad idea. The problem is that you don't have, I assume, detailed records on either the products or the management that other person is doing, correct?
We'll have information on what the project person is doing, but perhaps not as detailed monitoring and scouting.
Yeah. So if it was me, because knowing that you have so much space, I would pick a couple of plots and try a few different variables, because what you can do is run trials on the concentration of neem oil, the control, of course, which doesn't have any, and you could perhaps use either no, you're organic, so you wouldn't use a conventional, but a different type of insecticide or some type of deterrent that is perhaps more common in your area. I personally wouldn't rely on the information from a neighbor, because if they're not involved in the test with you, you probably don't either have enough control or enough detail on how they're managing or what they're using to use it as an effective comparison. And I think, you know, their plots being at least a few acres away is more than adequate for a buffer zone. So that's not the main thing. And then the other last part, of course, is that going straight into running an experiment on the entire size of your farm goes against that safe to fail concept, right? You don't want to learn that your hypothesis was wrong at the same time that you learn that it's also jeopardizing the financial success of your business, right?
100%. I mean, the financial side of using neem oil is extreme because it's expensive and it needs to be applied a lot.
Yeah.
But the flip side is really there aren't that many options to control insects organically.
Yeah. Yeah. So I would be more than happy to work with you, but I would go back to those steps of, like, first of all, really understanding what you're trying to learn from this. Is it just neem oil good, not neem oil bad? Because I think there's a lot more to learn from this, especially if you're willing to break up different plots, try different concentrations, or let's say different frequencies, and also understand which insects the neem oil is effective on and which it is not, right? Because there's very few products that are 100% effective across a very wide range of species in the insect world, right?
Yes.
Yeah. So yeah, so that I would look into, okay, what are you really trying to learn about this product? Can you get extra information from running these trials so that it isn't just a simple good, bad, yes, no outcome, because that lacks the nuance that you probably need to manage over, let's say, a particularly insect dense year over one where it's not as much of a problem. And isolate the experiment to the point where you can control it a lot more effectively and in a small enough area that you are not risking, you know, the yield of that year if you are wrong. Does that answer your question?
Yes, thank you.
Yeah, and I'm more than happy to make time outside of this to help you design that if you'd like.
Great. Thank you. We actually have some document we have written up very similar to your map, you know, on the hypothesis. If it's okay with you, I may send it to you to get your critical perspective on it.
Yeah, absolutely. And if you'd like, please share it in the group too. We could have a whole conversation with everybody's perspective on it as well, because the learning that you're doing right now, I promise you, is relevant to many of our other producers in the group. Thanks for coming, Miguel. Any other questions? Any other ideas that people would like to run experiments around? We could also go further into the development of the examples that we had at the beginning, or anything else you guys have.
This is not a question, but it just goes back to Ashes. I am also interested in the neem oil. I haven't used it at all yet. I just know that it depends on the larva cycle and, well, the insect cycle. But as Oliver was saying, if you get more information eventually, I would love also to hear from it, because that will give me a step on to know how it works, or just insights to know how to manage it in my field.
Sure, more than happy to share. And I can also, I mean, I think at the halfway stage of this experiment, one thing is for sure, it's a very expensive product for what it can deliver. And the way we are thinking of economizing on it is to actually grow our own neem trees from which we can get the seeds and then create the oil. Importing it from overseas is a very expensive proposition.
All right.
Real quick, Ashish, what are the main insects that you are trying to deter?
Okay, so there's really three main insects. So one is aphids, second is locust, and third is caterpillar. Now, locust, the neem oil is not going to be effective on. Aphids, it is expected to be quite effective. And I'm still trying to understand whether it works against caterpillar or not.
Yeah, this is interesting because I also know of plenty of success stories of alternative ways of deterring pests so that treatment is not necessarily necessary. For example, introducing ladybugs to eat aphids or planting certain types of flowers in the rows that deter other insects, right? And these are the types of things that you have more than enough space to trial alongside the application of something like neem oil, right? Now, obviously, I'm not going to tell you to take on that much complexity in your trials over a single season. But again, like you can do this in a fairly small and confined way to see if you can reduce, let's say, first of all, you've concluded that neem oil is an effective product. You can then start to see if you can reduce the cost of buying it or using it by integrating some other pest management strategies that are integrated into the landscape rather than just being a product that you have to purchase.
Yeah, so our next step after this is exactly what you just said. So for the bigger insects, we believe pytheroids or something like that is the chemical which is often used to deter them, and that is extracted from chrysanthemum flowers. So we want to sort of bring those into play in our fields.
Yeah.
But we're still growing them in our nursery, and we'll probably plant them next year.
Very cool. Well, man, you're doing really important work, and I would love to not only assist you as you do these experiments, but share these results. I mean, this is the whole reason why we've put these programs out there, is so that all of our farmers who are innovating in their own land can have a verifiable and more easily communicated, more communicable way of sharing what they're learning in a way that can be useful for others. That's why we've got the digital tool. It's why we're facilitating this process. And what you're doing is exactly the example of what we want to make more available for people.
Sure, happy to share.
Awesome.
If I can
Yeah,
butt in
Alberto,
a
you had
bit.
your hand up. Go for it, buddy.
Yeah. I don't know. Have anyone tried the sugar water or molasses for insect deterrent? I've heard that works pretty great. Depending on which crop you're using, sugar or refined sugar works great. Or something a bit more unrefined like molasses, and depending on the crop works pretty good, and it's relatively cheap. I know Russell has been doing it for a while in the States, and he's putting about £1 an acre, so very cheap per acre, and it kind of brings up the Brix level a bit on the leaf. And for locusts and stuff like that, when they bite into it, they'll just eat pure sugar and kind of deter them. I don't know.
Yeah, this works on that concept that all those invertebrates without a pancreas can't digest concentrated sugars, and they actually either die or are completely deterred. And so going directly by just increasing solid sugar on the outside makes it inedible for them.
And it's so inexpensive that it could be a nice something to test out. Yeah.
That is actually, I remember reading about this and commenting also on the chat, and I completely forgot about it. But the timing is so perfect. Baby locusts are just starting to come out. So they haven't quite sort of started damaging anything yet, but this would be the perfect timing to start spraying this. I think you've given me an action for tomorrow morning.
Yeah, that would be really cool to trial. Remember just to make sure that you set the proper parameters and do the measurement and the recording so that you get information that you can reliably kind of verify, you know? Another thing that would be interesting to check on is if you notice that certain areas or certain individual trees are more damaged than others. And by getting a Brix reading from those without any treatment or coating on the outside, might be able to tell you like, okay, a tree with a Brix reading below a certain number is uniquely susceptible to insect damage. And if you can generally raise the health, but through a Brix reading, higher Brix numbers for the entire orchard, if that has significant change in the susceptibility to insects, whether they're present or not. Because I know this was something we talked about before as we went through the plant health pyramid from EcoAg.
Yes, I think I can. I think I'll set up a plan, and I think the Brix reading is a good way of monitoring, measuring the impact. So
And that's
I
another
mean,
one
again,
super cheap and easy
chat,
to do.
yeah. Also, I think in the chat, the idea of a garlic press to get this. Now I sort of understand what it's
Yeah,
doing.
me and Felipe are working on that. See if we can get the right tool to actually get a drop out of some of these leaves. Nice. So we're about at the end of time here, but keep in mind we've got one more webinar, and the signups for joining the program are open until I think the end of the month. And so the next webinar will be on processes and those nice templates that I love so much, on making it easy to plan and prepare for execution out in the field, whether that's simply a management strategy or the experiments like we talked about running today. So I will catch up with you guys in the community up until then, and I hope that I see you again next Thursday for that other webinar. Thanks so much for being here, gentlemen. See you
Bye,
later.
everybody.
Thank you. See ya.